All right, welcome to the next video. Today, right now, we're going to be looking at the 11-2 practice where we practice factoring. We learned all those methods in our notes. Depending on what our equation looked like at the start, we had different methods of different levels of complexity to find all of our zeros. So let's start off. Remember, we said we were only doing these 6, and this one was extra credit. So, of course, I will not be talking about the extra credit one. So number 3, we have the function of x is equal to x squared minus 12. So we need to decide to ourselves, what can we do here that involves the least amount of work? If you love using the quadratic formula, you can. I don't like it, but here would be the correct values of a, b, and c to do this. I like trying to avoid the quadratic formula because I always feel like I don't remember it correctly, so I avoid it. So here what we can do, whenever we find the zeros, we're looking for where that curve, whatever it looks like, crosses the x-axis, which means f of x is equal to 0 at the x-axis. So we replace the f of x with 0 to say, where will this function be at 0 for the y value? We can just solve for x here. We can only do this if the degree is odd or 2. We'll see in other examples what we need to do if we have a bigger even degree. So here we can do this. We can add 12 on both sides. And I'm just going to rearrange it so that way it's normal. So we get x equals 12. We want to find x, so we're going to take the square root of both sides. And when we take the square root, we need to remember we always get the positive and negative version of that number. So we get x is equal to positive and negative square root 12. And now we need to see, can we simplify? And the answer here is yes, because if we try to break 12 up, we get 4 and 3, and we get a perfect square. The other way to do that is to break it up and look for repeating prime numbers, and these repeat. So however you do that, that's how we have to do it. I think most of us stay with how we learned it, and that was the perfect square method. So we get x is equal to plus or minus 2 times the square root of 3. That means there are 2 zeros because our degree was 2. And by 2 zeros, I mean, we could say our zeros is positive 2 times the square root of 3 and negative 2 times the square root of 3. And that we can see in a graph. So we could graph this to check our work. Number 4, if we check this, we have f of x is equal to x squared plus 6. Same method, we replace the f of x with 0. And now we're trying to solve for x. So we will subtract 6 on both sides to get x squared is equal to negative 6. Same method, square root, both sides, we get the plus or minus. But we have an issue here. We have a negative inside the square root, which means we have an imaginary number. So we can simplify this. We get x is equal to plus or minus the square root of negative 6, which we can separate into plus or minus the square root of negative 1, the square root of 6. We cannot simplify the square root of 6, but the square root of negative 1, we rewrite as I, just for simplicity. And so that way we can try to get it out of our mind and focus on simplifying the square root part. So that means x is equal to plus or minus I times the square root of 6, and we do always like putting I first. So if we wanted to rewrite this, which we don't have to, we know our 2 zeros are positive I square root 6 and negative I square root 6. This will not be on the graph. So here our parabola would look something like this. And we have 2 zeros, but we have 0 x-intercepts, because our zeros must be real to become x-intercepts. So that's why we don't cross the x-axis in this equation. Moving on to number 5, now we're increasing our degree. If we look at number 5, we have f of x is equal to x to the fourth minus 625. If we try to use the other method, we're not wrong. We just don't get all of our possible answers. So here we would get, and if we took the fourth root, we would get x equals plus or minus 5. We're not wrong. Those are two of our zeros, but we're missing out on two other zeros because we didn't notice that our degree was too big. So instead, we have to use one of our special properties. So we still want to set it equal to 0, but what we want to see is that we have a degree bigger than 2. It's even, so we need to try to break this apart into something. So we're going to deal with what's called the difference of squares. And that says if we have a squared minus b squared, that's a minus b times a plus b. So here, we're squaring x squared, and we're squaring 25. So we get 0 equals x squared minus 25 and x squared plus 25. So for here, we can split up. We get 0 equals x squared plus x squared minus 25. We can add 25 to this side, take the square root of both sides, and that's where we get the x plus or minus 5. So that's what we had over here. But we said we had more answers because of this one over here. We have 0 equals x squared plus 25. If we try to move it over, we get negative 25 equals x squared. And if we take the square root of a negative, that's when we get an I, right? So we can say x is equal to plus or minus the square root of negative 25. And we can break that apart into, take the negative out of negative 25. So 25 is just by itself. So we get x is equal to plus or minus, the negative turns into an I because it's in the square root. And the 25 turns into a 5. And we do like putting whole numbers in front of the I. So now we have all 4 zeros that we said we were going to have because our degree was 4. Number 6, we still had a big degree, but this one we have to try another way. So here we have the f of x is equal to 2x to the fourth minus 7x squared minus 4. So here we have an instance where we have this middle term that we haven't really seen yet. So we're still going to do a times c, which would be negative 8, and our b is negative 7. So we need two factors of negative 8 that add up to negative 7. And that would be negative 8 and positive 1. They multiply up to negative 8, add up to negative 7, so we can group it. And then we can split up the b term and then try our grouping. So we're looking at this, can we take anything out? We can take a 2 out, and we can take an x squared out. Here, we don't really have much we can do, so that's just a 1, and x squared minus 4. These two match, so that's why we can do the next step, which is using our distributive property backwards. So over here, we get 2x squared plus 1, and then x squared minus 4. So then the whole time we have this equal to 0. So now when we split these apart, we get 2x squared plus 1 equals 0, and x squared minus 4 equals 0. Here we have difference of squares, but we have a square, so we don't need to do the more complex one. We can just move the 4 over, take the square root of both sides. So we get x is equal to plus or minus 2. Over on the other side, we can still try to solve for x because our degree is 2. So we get 2x squared equals negative 1. X squared equals negative 1/2. And then we take the square root of both sides. So we get x is equal to plus or minus negative 1/2. Not a beautiful looking number. All right, but we still need to clean that up. So we can have plus or minus square root negative 1, square root 1/2. So x is equal to plus or minus I. And now we have the square root 1/2. We usually don't like square roots in fractions. So what we can do is we can split it up and put the square root separately on the numerator and the denominator. So then we get square root of 1, which is just 1. So the top of the denominator can just be I, the top of the fraction. And then on the bottom, we have the square root 2. We definitely don't like square roots on the bottom, so we need to multiply the top and the bottom by the same thing. So we get plus or minus square root I out in front over 2. If we did our quadratic formula, we might have gotten to our final answer a bit faster than if we did solving for x. So this case, it might have been easier to use our quadratic formula to get to this answer. So your choice, kind of just have to know how we are. But those would be our 4 zeros, which we know we have because it was degree 4. Moving on to number 7. All right, so number 7 said f of x is equal to x squared minus 3x plus 10. Let's try to look for factors. We need factors of 10 that add up to -3. So 1 and 10, no. 2 and 5, no. -1 and -10, no. -2 and -5, no. So no factors. We can't just solve for x by moving the 10 over, so this is one where we have to use the quadratic formula. So we have the values. Let's try to remember what our quadratic formula says, and we need to remember our song for that. So let's all sing together. Remember, I only know the one for Pop Goes the Weasel. So it's going to be x is equal to -b plus or minus the square root b squared minus 4ac all over 2a. Now you have me singing the song that you can listen to for the rest of your life if you ever miss life at the U. All right, so let's plug in our values. Negative of b plus or minus the square root of b squared minus 4, no, I'm just still saying it to the song, ac all over 2a. So when we're doing this on Tuesday during class, a lot of us were plugging into the quadratic formula and just making a couple of mistakes. Just take your time and be careful with it. So we have 3 plus or minus, and then we have 9 after we square the -3, minus 40 all over 2a, and we know a is 1. So all over 2. And we can start to see we will have a complex number because we get -31 inside the square root, but it's all over 2. We can try to clean it up, but 31 is not a good number, so it won't get simplified, but we can take that negative out by putting the I out in front and having it like this. Some of you might not like this and might have been told to separate it even further, which we can do. We can put the 2 underneath the 3, but then we would also need to put the 2 like this. I have no preference because I don't have a preference here, but this would be the more proper one because it is set up in our complex number notation. All right, number 8, which is the last problem we're going to look at. Again, we have a challenging problem where we have 5x to the 4th plus 5x to the 3rd plus 30x squared. You might have been looking at this and thought to yourself, oh no, this is going to be terrible. But we always should check ourselves and see, is there anything we can take out of everything? I can look at the coefficients. I have 5, 5, and 30. 5 goes into all of that. I can look at the x's and their powers. We have x everywhere, and then we use the smallest power. So if we take 5x squared out of 5x to the power 4, we're just left with x squared. If we take 5x squared out of 5x cubed, we're just left with x to the power of 1. If we take 5x squared out of 30x squared, we're just left with 6. So nothing too bad. But now we're looking for the factors of 6 that add up to 1. So the factors of 6 are 1 and 6. It does not add up to 1. And 2 and 3 does not add up to 1, -1, -6. No. -2, -3. No. So nothing works here. So again, we have to use the quadratic formula. I will save you from the song again. If you want to re-listen to the song, just rewind a little bit, and I will be there singing the song for eternity. But what happened here? X squared. So we set this is equal to 0, right? So we have 0 equals to 5x squared. We can divide both sides by 5. So we get 0 equals x squared. Take the square root of both sides. We just get x equals 0. But that would have a multiplicity of 2 if we always want to talk about that. But next we need to use the quadratic formula. So there, that other way that we talked about it was with that story. So there once was a negative boy who couldn't decide to go to the radical party. The boy was square and he missed out on 4 awesome chicks, and it was all over by 2 a.m. So we have negative b, so -1 plus or minus the square root of b squared, so 1 squared, minus 4 times 1 times c, which was 2, all over 2 times 1. So if we start cleaning this up, 1 minus 8 where did I get that 2 from? That's a 6. Okay. All right. Minus 24 all over 2. So we get -1 plus or minus the square root of -23 all over 2. So we can try to clean that up. We're pretty much done. -1 plus or minus. We can take the negative out, but we cannot simplify the square root. So again, that could be an answer, but we can also separate it by dividing both of those terms by 2. So we get -1/2 plus or minus I over 2 times the square root of 23. So either answer, but of course the second one's a little bit more correct because they're separated. And we do have 1, 2, 3, 4, because that plus or minus zeros here. So that would be the answer for those 6 problems. Number 9, find the zeros of this given that 4i is a 0. So I said this is extra credit because I like the synthetic route better versus this. So for number 9, we should be graphing it and seeing where our real root is. And we could be using our rational root theorem to find the list of possibilities. You should be doing that. And I think we get something. And then once we get to the end, after synthetically dividing out that real x-intercept, we will get to a quadratic that then if we plug in or just solve it, because I don't think we'll have a middle term, once we just solve it, we get -4i and +4i. So again, not telling you the answer, but trying to give you a little setup so you can look at your extra credit. So that is the end of the 11.2 homework.